Good morning, my YouTube viewers. Crystal here. This is the morning of Sunday, 31 January 2021. I'm here this morning because I wanted to make another video for you. The title of this video is going to be how I scored 100% accuracy on the wine data set. And what I'm going to do is I'm going to go over with you what I did to score 100% on this data set, which I'm quite happy about. I've never scored 100% before. I know it's an easy data set because it's a data set in the sklearn library, but it's still an achievement nevertheless. And because of that, I wanted to go over the code with you. I will be making a code review, and I will be making a blog post. And when I make the blog post, I will leave you a link to the GitHub repository that this file is saved in if you actually want to look at the code. So what we'll do now is we'll go over the code review of this code that I made yesterday. It's the original UCI wine recognition data set. I originally got the data set off of the sklearn library, but with the sklearn library, what they had done is they had they had standardized the data and then put the data into the library, and as a result of that, you couldn't do any exploratory data analysis on it. And because you couldn't do any exploratory data analysis, it really wasn't, as useful as it could have been. So I went on to the UCI, that's University of California, and I'm not sure exactly what the I stands for. I think the I is the city that the University of California is in, but I don't know the city. But I went onto the UCI website and I downloaded the file, but the file was not even a CSV file. It was just a text file. So I had to save it onto a Microsoft Word document. But fortunately, what happened was, because it was CSV, even though it hadn't been saved into a CSV file, it was CSV. So fortunately, Python actually read the file and I was able to use it. And so I actually saved the CSV file on my GitHub repository, although it's not called CSV. I think it might be called data or something like that. I can't remember right now, but it is actually on my GitHub repository if you want to borrow it and use it. So now that you know a little bit of the background, what we'll do is we'll actually go over the code review. So this is a copy of the UCI ML wine recognition data set, and you're given a link to the data set. The data is the result of a chemical analysis of wines grown in the same region in Italy by 3 different cultivators. There are 13 different measurements taken for different constituents found in the 3 types of wine. So what I do is I give you a remark, and then I give you the 3 types of wine. I give you the categories that are actually found in the sklearn library, because when you actually get the data set comes without the names of the columns. I think that you can actually download the names, but I'm hoping that the names that they give you on sklearn are the same as the names that are actually in the data set, because they say that it's a copy of the file. And if it's a copy of a file, then surely it would be the same. And so what I did was I created this file in Google Colab. And Google Colab is a free online Jupyter notebook. It's got Python and many of the libraries already installed in it. But one thing that I'm really disappointed about is the fact that Google Colab does not keep the most current versions of the libraries installed on it. And as a result of that, if a library has something really neat and it's in a newer version, then you cannot access that on Google Colab unless you install the most current version of that library on Google Colab yourself. But I didn't particularly want to do that, but you can do that if you need to. So I imported the files. So data equals PD read CSV, and the file is called data, and so it actually read it. So I guess it's not really that picky about whether it says CSV on the end, just so long as the file is actually a CSV file. And so what I had done is I had downloaded that file onto a Word document, and then I saved it as a data file, and that's how I did it. And then so I named the columns. Column equals Y, alcohol, malic acid, ash, alkalinity, magnesium, phenols, flavonoids, non-flavonoid, proanthocyanin, color, hue, diluted, and protein. And then it put it into a data frame. And so here's your data frame with 177 rows and 14 columns. The Y column is your target column. It's going to be 1, 2, or 3, and it's based upon 3 different regions in Italy where the wine was cultivated. So what we do is we check for any null values, and in this instance there are not any null values, so we do not have anything that we need to impute. And now what we're doing is we're starting our exploratory data analysis. And so what we do is we make a heat map. So if you like heat maps and you want to see how the different variables relate to each other, well, here it is on the heat map. The heat map tells you how they all come together. And now what we did is we did a disk plot on Y, and so you can see that Y is 3 different classes. It's 1, 2, and 3. So we counted them. On 1 there's 58, 2 there's 71, and 3 there's 48. And I will say that there's just a slight difference between this data set and the actual data set that we got off of sklearn. I think there's one example difference, although this particular video recorder that I'm using, or screen recorder that I'm using, it will only allow me to record on 1 tab, so I can't find it to show it to you, unfortunately. But I do think that there is a slight difference between the data set with UCI and the data set with sklearn. But moving along, what we did was we did a disk plot on alcohol, and you can see that the level of alcohol ranged anywhere from 11.03 to 14.83 with the median of 1305. We did a disk plot on malic acid, and it ranged anywhere from 0.74 to 5.8. We did a disk plot on ash, and it ranged anywhere from 1.36 to 3.23. We did a disk plot on alkalinity, and it ranged anywhere from 10.6 to 30. We did a disk plot on magnesium, and it ranged anywhere from 70 to 162. We did a disk plot on phenols, and it ranged anywhere from 0.98 to 3.88. We did a disk plot on flavonoids, and it ranged anywhere from 0.34 to 5.08 with a median of 2.13. We did a disk plot on non-flavonoids, and it ranged anywhere from 0.13 to 0.66. We did a disk plot on proanthocyanins, and it ranged anywhere from 0.41 to 3.58. We did this disk plot on color, and it ranged from 1.28 to 13 with a median of 4.68. We did a disk plot on U, and it ranged from 0.48 to 1.71. We did a disk plot on diluted, and it ranged anywhere from 1.27 to 4.0. We did a disk plot on proline, and it ranged anywhere from 278 to 1680 with a median of 6.72. And after we did our exploratory data analysis, what we did was we defined our X and our Y variables. And so Y is data Y, and X is data drop Y axis equals 1. So you can see Y, and then you can see X. Now what we've done is we have normalized the data. I use the code X equals X minus X min over X max minus X min. So now all of the data is normalized to a value between 0 and 1. I put the code in to standardize it, but it worked better to normalize it, so I just kept it on normalized. I split X up into training and validation data sets with a test size of 0.1 and a random state of 1, shuffle equals true, and I didn't stratify it because if I stratified it, it made the accuracy less. I'm not sure exactly why that is, because they say that if you have a class imbalance, you're supposed to stratify. So I'll have to do some more research on stratify and find out exactly why it decreases the accuracy. To find my model, I just decided I would guess, and I used the radius neighbors classifier. I just guessed it. I just picked it out, and I got 100% accuracy using that model. So that was really good. I predicted on my validation set, and I got 100% accuracy when I predicted on my validation set. I put it on a counter, and 1 was 7 points, 2 was 9 points, and 3 was 2 points. I put it on a confusion matrix, and you can see that the confusion matrix showed that there were not any errors. Put it on a data frame so you can see the actual values against the predicted values, and you can see they're all the same. And then I put it on a chart, a graph, and you can see that there are not any yellow dots, so that means that there were not any incorrect values. So that concludes this code review. So this is the first time since I've been working on data science that I've got 100% accuracy, although I know that this was an easy data set to work on, but we'll keep working on it and trying to improve my score to see if I can get 100% accuracy on perhaps a Kaggle competition. That would be good. So if you like my video, please like, subscribe, and share. If you want to receive a notification of whenever I make a video, please tap on the bell button by the subscribe button, and you will get a notification every time I make a video. If you like the work I do and you want to support me, I have my email address to my PayPal account in the description box down below. I have to ask for donations because I don't have enough subscribers to monetize. And thank you so much for watching this video, and I look forward to making new videos for you in the future.